Now, we all know that there are many conspiracy theories out there which are just beyond ridiculous. Flat Earth, moon hoaxes, or evil pharmaceutical companies trying to hide the cure for cancer. Now, there is a constant narrative around secret things that they just don't want you to know. These conspiracies are big. And for there to be a conspiracy of this magnitude, there must be a lot of co conspirators. Now, the Apollo missions involved around 400,000 employees and countless contractors, and all of these must be in on the moon hoax. The pharmaceutical industry employs roughly 4.4 million people worldwide, and they all have to be evil bastards intent on hiding the cure for cancer. There are probably more than 8 million scientists in the world who would all have to be in on the secret that the Earth is flat and climate change is a hoax. Now, that's a lot of people. So, how likely is it that a conspiracy like this can survive? Well, actually, someone did the maths, and the following video is an outline of a paper by David Robert Grimes published in PLOS One entitled On the Viability of Conspiratorial Beliefs, and this explores this very issue. Now, we start with a useful definition of a conspiracy theory given by Sunstein et al. And this definition states that a conspiracy theory is an effort to explain some event or practice by reference to the machinations of powerful people who attempt to conceal their role. Now, this is a useful definition because it allows for the conspiracy theory to be true. To start building the model, we assume that a leak from any of the conspirators can lead to the failure of a conspiracy, and this leak may be intentional or accidental. Now, using Poisson statistics, the probability of a leak is then given by this expression, where phi is the probability of a leak per unit time. Now, to figure out phi, we take the probability of a person leaking a document as p, and then the probability of not leaking is 1 minus p. We can then raise this to the power of number of conspirators to give the overall probability of success, and then we subtract all of that from 1 to get the probability of failure. And this gives us this expression. We then stick it into our expression for the probability of failure. Now, you'll notice that the number of conspirators is a function of time, and this allows us to account for new conspirators being brought in. And as you have to take the secret to the grave, existing conspirators could be dying. Now, if we assume that the conspiracy involved a single event such that there are no other people being brought in, then we can approximate the number of conspirators as a function of time using the Gompertz survival function given by this expression. And this describes the probability of an organism surviving a given time, or the population of an organism surviving a given time, provided that no additional members of the species are being brought in. For humans, we can take alpha equals 10 to the minus 4 and beta as 0.085. And then TE is the average age of the conspirators when the event happened. Now, of course, this doesn't account for paranoia. If we were to take a tasty Hollywood narrative, then all the conspirators will be trying to kill each other off to keep the secret. And in this case, we will assume exponential decay. But as the incentive to go public would increase, P would then also likely be increasing. But that gets messy, and so we'll treat P as constant, and actually this would work in favor for the conspiracy nuts. Now, this is all great for a conspiracy involving a single event. But as conspiracies can be complex thing which goes on for a long while, it could very well be that people die and new conspirators will need to be brought in just to keep up staff. Now, assuming that the replenishment rate is equal to the death rate, N will remain constant. But some conspiracies are really big, namely conspiracies which involve pharmaceutical companies hiding the cure to cancer or flat Earth. In the case of the former, we have industry professionals who have to be in on the secret. In the case of the latter, every scientist, politician, pilot, sailor, and many other professions will need to be in on it. And to cut another bit of slack, we'll just consider scientists as conspirators only, because scientists are the best, obviously. No, they just make up a large group, and we have some nice statistics around this. Now, the issue is that both the pharmaceutical industry and the number of scientists are increasing exponentially. So we'll reflect that with a function for n which increases exponentially over time. So here we have it. We have four models for the number of people involved in a conspiracy. We have these expressions for the number of people. Now here you see t sub half is the number of years for the figure to double in case of exponential growth and halve in the case of exponential decay. For the number of scientists, that t half is roughly 18 years. Now before we start plugging in the values, we need a number for the probability of the leak. Well, the paper actually discusses these estimates and bases them on true conspiracies, including NSA PRISM and the FBI evidence scandal. And they come out with a range of, well, between 5 times 10 to the minus 6 and 10 to the minus 4. But we will be conservative and take their lower bound at 5 in 1 million chance of a leak. The numbers for the Gompertz function come from standard survival statistics of the human population. And as I already said, alpha is around 10 to the minus 4 and beta is around 0.085. So here is a plot which shows the probability of failure of a conspiracy, any conspiracy involving 5,000 people, and taking the probability of an individual leaking at 5 times 10 to the minus 6. We have the model for a constant number of people, constant n, where the probability of failure increases with time. For a model with number of conspirators growing exponentially, the probability of failure also increases dramatically. When we have conspiracies which are about covering up a single event, we see the probability increasing initially, but then leveling off after a while as people start dying off. Of course, the best chance you have at getting away with whatever event you're trying to cover up, it is best to actually get everyone to bump each other off. Now let's look at some real conspiracy theories. We start with the moon landing hoax. Now, considering that during the Apollo program, NASA had around 400,000 people involved who would all have to be in on it, and will take the average age of 40. Now, many aficionados will probably tell me that this estimate is too high, but I'm really being generous to the conspiracy nuts here. Now, which model to use is actually a difficult question. We could make a reasonable assumption that during the Apollo program, not a significant number of people died, and some people may have left and some people may have joined. So let's just take it as a constant during the program. Of course, since then, a lot of the people involved would have died since the end of the Apollo program. So maybe we could switch to a Gompertz survival curve after the end of Apollo. But let's just run the model for, well, for the Apollo program whilst it was still running. Oh, well, fuck it. It doesn't matter. The secret would have been blown before, well, they managed to get anything done. After the first year, the probability of failure was already greater than 50% and pretty much certain by the time Apollo 11 launched. There is no way that they could have kept this secret. But now let's have a look at Flat Earth, because this is a massive conspiracy in which all scientists would have to be involved. Currently, it is estimated that there are roughly 8 million scientists who are active today. And let's say that the conspiracy began in 1838 when Rowbotham did his Bedford level experiment. The number of scientists has been doubling roughly every 18 years. So we can work back to 1838 to figure out the number of scientists that were around at the time. And we can do this with this simple equation. Now here, delta t is the number of years between 1838 and now. T2 is the amount of time required to double the number, and that's 18 years. This gives us around 7,500 scientists at the time of the Bedford level experiment. But there is one more bit which is quite uncertain, and this is the probability of an individual leaking. Now, with the moon hoax, I use historic data based on leaks from intelligence agencies. However, scientists are really shit at keeping secrets. So what I'll do is I'll present a few scenarios with different probabilities of an individual leaking. Here's the plot. And if the probability of a leak is as small as 1 in 100 million, then there may be a small chance that the Flat Earth conspiracy would not have been leaked sufficiently to be exposed. And just to highlight, this probability is 2 orders of magnitude smaller than the paper's most conservative estimates, which were based on historic conspiracies involving intelligence agencies where leaks are a serious criminal offense. When we take the probability that was estimated for the NSA leaks, then the cat would have been likely let out of the bag towards the end of the 19th century, and definitely by World War II. Now, if it were on the larger end of the estimates, then the cover would have been blown by the 1850s. Now, the upper end of estimates is a probability of leaking at 1 in 10,000. So from my personal experience with scientists working on non-military projects, the probability of a leak is probably closer to 1 in 10, 1 in 100 if you are being generous. Now, of course, you would say that, well, not all scientists could be aware of the truth. And there's a simple answer to that, and that is no. Flat Earth goes against many laws of physics, and if the Earth were flat, then we would know it. After all, anyone can measure it. All you need is a stick, a tape measure, and some common sense. So with that, thank you for watching, and until next time.